Welcome, ladies and gentlemen, to this video lecture. Let's take a look at this example. Okay, so we have a function on this following open interval up to plus infinity defined as follows. Prove using the definition that the limit as x tends to plus infinity of f of x is equal to 2. Okay, so let us do that. So firstly, let's write out exactly what we have to prove. Let's write out what this statement means. It means for every epsilon greater than 0, there exists an m greater than 0, so that if x is bigger than m, then the function value is within an epsilon distance of 2. So this is what we have to prove. Okay, so let's write our proof outline. So we want to fix any epsilon greater than 0. We have to show that there exists an m, so we must define an m. Define m as something, should be bigger than 0, and we are allowed to use epsilon in defining our m. Okay, then we want to assume that x is bigger than m, and now we have to work, and then we have to conclude that f of x minus 2 is less than epsilon. Okay, here is our proof outline. So let me duplicate this page, and we will then write our proof for realsies. Okay, where's my duplicated page? Let's try again. There it is. Okay, so let's write our proof. Okay, let us start over here. We want to get this expression less than epsilon. So let us look at, immediately, so look at f of x minus 2. How is f defined? 2x minus 1 over x plus 1 is equal to 2x minus 1 over x plus 1 minus 2. And let's write it this way. This is multiplied with x plus 1, x plus 1. Let us simplify everything over x plus 1. That becomes minus 1 and also minus 1, so minus 2, minus 2, absolute value. So this is the same as 2 times over 1 over the absolute value of x plus 1. However, m we are going to define as being positive anyway, so we might as well get rid of these absolute values. So since x is bigger than m is bigger than 0. Okay, now also let us take a look here. X plus 1. So x plus 1 is bigger than x, which is going to be bigger than, which we have assumed is bigger than m. So if you add something to a number that is bigger anyway, and that is bigger than m, which is bigger than 0. So let's take a look at this part. This means 1 over x is less than 1 over x plus 1. And be careful here, this works since everything is positive. So this is less than 2 times 1 over x. Okay. But x is bigger than m. Let's add here, since x plus 1 is bigger than x. But also we've got x is bigger than m. So 1 over x is less than 1 over m. And m is bigger than 0. So since that is the case, this is less than 1 over m. So now we see here, what do we want? We finally want this thing to be less than epsilon. So if we choose our m to be 1 over epsilon, what happens here? This becomes 2 over 1 over epsilon. Actually, not 1 over epsilon, 2 over epsilon. 2 over epsilon. This becomes 2 over epsilon over 2. The 2's cancel, and we're left with epsilon. And we're done. And there is our proof. Let's add here. How do we get from here to here, since m is equal to 2 over epsilon? Okay, and that finishes this example. I will see you in the next one.